explicit command and query objects to do its work. And because of that, the controller itself has become a thin wrapper on top of these commands and queries. In theory, you could even remove this controller. There's not much value in it anyway. Here you can see all it does is it creates commands and dispatches them. In practice, however, there is just too much of internal ASP.NET wiring that is tied to the presence of controllers. For example, the HTTP method, such as GET or POST, and URL routing. So it's impossible to get rid of controllers entirely, but you won't be using them for anything other than this ASP.NET wiring stuff. All the application logic will go to the command and query handlers themselves, which is a good thing. Note once again how we leverage the ASP.NET dependency injection mechanism for the resolution of command and query handlers. Our messages class uses the internal ASP.NET's service provider to resolve the command handler of the required type. For that, it constructs the iCommand handler interface using the type of the command argument. Very convenient indeed. The drawback of this approach is that we now need to manually configure all those handlers one by one in the startup class, so that the service provider knows which class it needs to create to resolve a given interface. You can mitigate this issue by using a dependency injection library. Most of such libraries can scan your assemblies for all implementations of a particular interface, so that you don't have to register them manually. Or you could write this functionality yourself. It's just a couple lines of code to do this using reflection. I'll leave it to you as an exercise. Note the difference in the semantics between the command handler and the query handler. The command handler returns an instance of the result class, a special class that represents either success or a failure of the operation. It also allows you to pass an error message in case of a failure. The command doesn't return anything other than this confirmation of the operation's success. It follows perfectly the semantics of a command. A query, on the other hand, does return an actual result. It's a bit confusing here because the difference in code is just a single letter. But there's actually a big difference between result and t-result. As I mentioned, the result class is just an acknowledgement of the operation's success or failure, whereas t-result is a type parameter and it can be of any type you'd like. In our sample application, the single query we introduced returns a list of student DTOs. Note that you can make this return type an instance of the result type too, and that would be a result of t-result. This is useful when you know that the query operations can fail too, for example, due to issues with the database connection, or if the query parameters can be invalid and you decide to prohibit the execution of invalid queries. In this module, we refactored our application towards using explicit commands and queries. All our application code now resides in separate command and query handler classes. We also introduced a unified interface for all our command and query handlers. This will help us in the next module when we'll be working on decorators for them. ASP.NET Core has a great dependency injection mechanism out of the box, and we've leveraged that mechanism for the handler resolution. Let's recap the key points of this module. First, the difference between commands and queries in CQS and CQRS taxonomies. In CQS, which stands for the Command Query Separation Principle, a command or a query is a method that either mutates the state of the application and doesn't return anything to the caller, or does return something but doesn't leave any side effects in the application state. In CQRS, which stands for Command Query Responsibility Segregation, a command or a query is a class that represents what you can do with the application. This class has a handler with a single handle method, which also follows the CQS principle. It means that the handle method of a CQRS command handler doesn't return anything to the caller, aside from the confirmation of the operation's success or failure, and the handler method of a query handler doesn't incur any side effects. As you can see, the definitions are quite interconnected. You can view a CQRS command as a serializable method call, and a command handler as a regular ASP.NET controller with just a single method, that is, a command in the CQS sense. All messages in an application can be divided into three categories: commands, queries, and events. A command is a message that tells the application to do something. A query is a message that asks the application about something. And an event is an informational message. It tells external applications about some change significant to your domain. It's important to properly name all three types of messages. Commands should be in the imperative tense. They are telling the application to do something. This naming guideline also implies that your application can reject this message. On the other hand, an event is a message that should always be in the past tense. That's because it states a fact, something that already happened in the past. It also implies that there is nothing the application can do about this message. The change it informs about has already taken place. Queries should follow the same naming guidelines as commands, except that in the vast majority of cases they should start with get. Always use the ubiquitous language when naming the messages. It will allow you to avoid the fallacy of the crowd-based thinking that we discussed in the previous module. We discussed where to place commands and queries in the onion architecture. They should reside in the core domain layer, the same place the domain events belong in. The only difference between commands and events is that the commands follow the push model, whereas the events follow the pull one. It means that it's the other applications that trigger the commands, and it's your application that triggers the events. We talked about the differences between commands and DTOs. In a publicly exposed API, you need to have both. DTOs, data transfer objects, allow you to achieve backward compatibility, whereas commands allow you to explicitly state what your application can do. Don't combine these two responsibilities unless you don't need backward compatibility for some reason. In the next module, we will discuss how to implement decorators upon the command and query handlers. It can be a very powerful mechanism that allows you to achieve great flexibility with little effort and maintenance cost.